taking functions. In functions, there are the infamous thinking and inquiry questions, right? Where students write the test and they're like, Miss Sly, you never taught us how to do question 6. And I will say, you are correct. I did not teach you how to do it, because one of the categories that we test you on is thinking and inquiry. So we're not testing whether you can regurgitate it. We're testing your thinking. How do you process information? How do you do a question that is new to you? Like, you have the tools, but do you know which tools to use? Okay, so that's why they're so hard, because you'll be like, you've never seen the question. However, you have the tools to use it. So that's why being solid in grade 10 stuff is going to be helpful. Now, this question is a good example of a thinking inquiry question, where we are going to use 3 other units to solve this question. Yes, it's unit 6 trigonometry, but guess what? We're going to look at unit 1, 2, and 3, and we're going to use ideas from it to solve this question. So the thinking inquiry questions, they use all the skills you have. Please stop talking. So look at this example. Try to understand what they're giving, what you were asked for, and try to understand why it's actually very difficult. Yep. 15. Does anyone see? Put your hand up if you can see why it's difficult. Okay, so let's break it down. So let's say I'm not sure. Well, how many triangles are there in this diagram? Show me with your fingers. There are 3 triangles. How many of them are a right angle triangle? 2. Okay, so because we're doing SOHCAHTOA right now, because you're not allowed to use sine law, some of you know sine law already, you're not allowed to use sine law for this, otherwise it's too easy. We have 2 triangles that we're working with. So if I don't know, so the other thing I'm going to show you today is what to do if you don't know what to do, right? Because you get part marks. So the first thing I would do is be like, there's 2 triangles. Why don't I draw them each separately? Okay, so I'm going to use color to help you understand what I'm doing. If you want, feel free to use color. So I've got triangle KNL. And what do I know about it? Well, I know that's an X. I know this is 69 degrees. That's about it. Then I've got this other triangle. I'll make it blue. It's also a right angle triangle. This is 48 degrees. This is again an X. Let's label it L, N, M. Then I've got that 60, but I'm not really sure what to do with it yet. So now you're looking at these diagrams and saying, Miss Sly said it's a really hard question. So look at each of these triangles, and can you understand what the problem is? Why is it not just going to be super easy? Talk to the people near you. Talk about it. Can you see why it's hard? Yeah, can you see why it's hard? Jules? Here's the question. Do we have enough information? Right? We don't know what the little. Yeah. Yeah. So folks, what is the problem here? Yeah, Juliana. Gorgeous. Or what's another way we could say it? Yeah. They are all right angles. These 2. Not the third one, Okay, what's yet another way, Ella? Good. All right, guys, come back to me. So that's right. We don't have 3 pieces of information. Now, when we say 3 pieces of information, I could say, hey, I know all 3 angles, right? Because I could find the third angle. But we're seeing that one of that piece, when I need 3 pieces, one of those pieces must be a length. Do I know any lengths here? I don't. Okay, so that makes it hard. So when you see this kind of question where you don't know a length, when you can't just easily solve one of the triangles, you're like, oh, that's one of the tricky ones that Miss Sly was talking about. So now we have this 60 situation. What we are told is that this plus this equals to 60. Well, but I just want to know like what one of them is. So when I don't know, the strategy is make up another variable. Give me a letter. Claire, give me a letter. A. All right, I'm going to call this length here A. I don't like making new variables, but I've got no choice. So if I'm making this A, what is this length going to be now? 60 minus A. Not great. Don't love it. But at least I can write something down. Now, before we move on, Grace, how many variables do we have? Show me with your fingers. We've got X, and we've got, what else do we have? X and A. The variables, we can call them unknowns because we don't know their value. So if we have 2 unknowns, how many equations do I need to solve for them? Show me with your fingers. 2. If I have 3 unknowns, how many equations do I need? 3. 4 unknowns, 4 equations. So the question is, can I come up with 2 different equations for this? Okay, talk with your group. Where could I get 2 different equations from? All right, who is going to risk it? Who wants 3 points just for trying something? All right, give it a shot, Audrey. So an overall, if I can rephrase what you're saying, Audrey is saying, take that blue triangle and make an equation for it. Yeah? Is that what you're saying? Where else can you get another equation from? There you go. That's why I like using colors. I can get an equation from the orange triangle, and I can get an equation from the blue triangle. And do you know why this works? Is because in both of those triangles, just ignore him. Just let him go and sit. Not you. Alex, just let him sit down. So in the orange triangle and in the blue one.
Hello, Humberside. Can we ask that all singers and dancers for the number All That Jazz from Chicago Teen Edition please come to room 129 at 1:50 p.m. for a very brief but important meeting with Miss Joseph and Miss Pelosi. Again, singers and dancers from All That Jazz.
So basically, these two X's are the same thing, right? Because it's just the height of the triangle. And then the A and the A, again, is talking about the same number. So because of that, we can write 2 equations and then substitute them into each other. So let's start with the orange triangle. And to show that I'm using the orange triangle, I'm going to write in triangle KLN. And then it's like, oh, she's working in the orange triangle because she called it KLN. This is going to happen a lot in these questions. There is one ratio that comes up the most. In this orange triangle, which side am I not using? O, A, or H? The H. I'm not using the hypotenuse. In the blue one, which one am I not using? Interesting. So which out of SOHCAHTOA, or sine, cosine, tangent, which one does not use the hypotenuse? Okay, you're going to notice that a lot in word problems is we use tangent a ton. Okay, if there's no hypotenuse, we're using the tangent. Okay, so let's write an equation. So we can say tan 69 degrees equals opposite over adjacent. So it's going to be x over a. Did you already do this question? Okay. But let Sebastian listen, okay? Let Sebastian listen. Okay, now I want to have one of the variables isolated. I want like either x equals or a equals. Which one is easier to isolate? No, it's actually easier to isolate x. Watch this. If I multiply both sides by a, then these cancel out, and I get that x equals a times tan 69 degrees. Okay, this is like going back to linear systems and using equations. Please stop talking. Please let him listen. Oh, okay. No. If you multiply x by x, it would be x squared because it's at the top. Yeah, good question. So I'm going to call this equation 1. Yeah. Like this, n equals? Yeah. Well, I think you mean like, how do we know if we're talking about this n or this n? Yeah, so the way that I would know is I'm specifying, hey, I'm working inside this triangle. So when you state that, and I say angle n is 30 degrees or whatever, 21, it's clear that it's inside, it's this angle because I stated, hey, I'm working in that triangle. All right, let's write the blue equation. So let's be clear. Hey, I'm working in triangle LMN. Now again, I'm not using the tangent. Sorry, I am using the tangent because I've got nothing on the hypotenuse. So let's write it down. Tan of 48 degrees equals opposite over adjacent. Uglier, right? Because the denominator has a binomial. It's okay. And we're going to use the exact same process to isolate the x. So I'm going to multiply both sides by 60 minus 8. And that allows me to cancel out the identical numerators and denominators. And so I get an equation that x equals 60 minus a, all in brackets, times tan 48 degrees. And that's my equation 2. No, you do not need to put the multiplication symbol. Brackets mean multiplication. Yeah. Okay, so now we said that x and x are identical. So what we can now say is equation 1 equals equation 2, right? Because the x is the same as the x. Well, I'm just going to take the other side of the equation, this one, and I'm going to say, okay, a times tan 69 degrees equals, I'm keeping it in color just so you know where everything is coming from. Okay. So I've already used unit 1, linear systems. Guess what? Unit 2 is coming in. I'm not sure what to do here, but I'm going to do something. What is something I can do in the blue side? Expand unit 2, right? I can go this times that, this times that. So we're bringing in expanding. So the right side doesn't change. Sorry, the left side doesn't change. The right side becomes 60 tan 48 minus A tan 48. What am I trying to do? I'm trying to find the value of A. So to do that, you need to isolate A. So let's bring everything that has an A to the left side. And let's leave anything that doesn't have an A on the right side. So the 60 times tan 48 stays. And then I'm moving. Okay. So we have used linear systems. We have expanded. Now let's do unit 3. I don't know if it's unit 3. What can I do on the left side? What's the F word, folks? I can factor, right? What is the common factor here? In these two, in this term and this term, what do they have in common? So guess what? We're going to factor out the A. We can't factor out the tan because this is a unit, tan 69 and tan 48, right? That's a separate unit. But we can factor out the A. And then I get tan 69 degrees plus tan 48 degrees equals 60 tan 48 degrees. Almost there, folks. Right, so we factored. I'm going to write that down. Factor out A. Now, yeah. Yes, this is going to be the challenge question on the test. I'm telling you ahead of time. It's going to be a version of this question. Couldn't tell you. I haven't written the test yet. So now we're going to divide both sides by this part that I want to get rid of. Right? I need to do that so that I can isolate A. Tan 69 degrees plus and because the numerator and denominator have an identical factor, I can cancel them. So on the left side, I'm left with A. And on the right side, I have this ugly calculation. And now it's a matter of, hey, can I use my calculator correctly to get this value? So get your calculator out. Okay, let's see if everyone's got their calculator. I love it. Use brackets. 1 decimal. Guys, we're not leaving yet, are we? Oh, I keep forgetting that my okay, and I get 17.9. I'm pretty sure it's 17.9. Anyone else? I think I got that in the morning. 18.1, you must have rounded somewhere, Alex. Do you see what I mean? I know what you did. I know what you mean, Alex. So if you're going to do that, how many decimals did you keep? Maybe keep 4 decimals just in case. I know. I'd prefer, Alex, that you don't. Good. Just because this is better communication, right? And Alex, I want you to feel comfortable not changing it into a number, right? It's harder. This is like more like, but you can do it, right?